We're now going to begin our final case study in the context of the WebMVC features that are provided by Spring. So far we've talked about, I think, 3 or 4 other case studies, and this is, I think, the 5th and final one that focuses on synchronous communication using Spring WebMVC. And this particular example is really important because it's going to start introducing a bunch of more Spring features that, number one, are actually how people build systems for real, number one, and number two, will relate to what we're going to do for the next programming assignment number 2. So what we're going to do here is show how we can use some really cool features, including some concurrency features, some persistence features, some other things having to do with the way in which we break our system up into microservices, multiple microservices, using something called an API gateway. And we're going to do this in the context of a fun application that will provide quotes from various sources. Once again, remember, this is all synchronous HTTP GET and POST requests and response. So what's going to happen here is we're going to have a driver program that's going to send requests to an API gateway. I will explain what an API gateway is in a second. And the API gateway will be responsible for routing those requests onto the appropriate microservices to handle the requests. And we're also going to show how to use the Eureka Discovery Service, which is another cool feature we're going to talk about here. So the client, in this case, is going to send requests only to the API gateway. It's not going to send it to the microservices directly. Up to this point, our clients have been talking directly to the microservices. And as we've discussed, there's pros and cons to that approach, but we're going to focus on this more production-ready, scalable way of designing systems using Spring. The API gateway will receive the requests from the clients, and then it will route them to the designated microservice. So we're going to have 2 different microservices. One that's going to give quotes from Jack Handy, another is going to give quotes from Zippy the Pinhead, which is always fun to see the quotes from these different sources. And when the microservices are routed, the requests from the clients, they do their thing, and then they send the responses back directly to the clients. The gateway is only there to route incoming requests from clients to the appropriate microservice, but the microservice then responds back directly to the clients. So that's kind of the high-level view of what we're going to do. And you're going to see this is going to introduce us to a whole bunch of really cool concepts here having to do with API gateways and server-side discovery and stuff like that. The QuoteServices app project source code is organized into a number of different modules and packages, but for once it's going to be more interesting than what we've talked about before, because we're going to have multiple pieces. We're going to have a client part, we're going to have a gateway part, and a bunch of microservices. And we've factored the code out in clever ways to maximize reuse and minimize redundant repetition of things that can be factored out. So let's talk first about the gateway. So the gateway contains the entry point for the overall API app perspective. From the client's point of view, it's just talking to the API gateway. And as you can see, there's a couple of files, the gateway application and the gateway controller. The code in these files is largely boilerplate. In other words, when you look at this, you'll see that you could reuse this code for just about any API gateway. And that's intentional, that's by design. There's also a very important folder called resources that specifies the port numbers and the microservices that are exposed by the API gateway. And these are written in something called YAML, which is a funny acronym that stands for YAML ain't a markup language, which I think is rather funny. So that's what YAML stands for. We'll talk a lot more about YAML. And then we've got the microservices project, which has the entry points into the different microservices. And once again, we've designed this in a very interesting way. So as you can see here, we've got a microservice for the handy quotes. We'll talk more about the handy quotes. We've got a microservice for the zippy quotes. We'll talk more about the zippy quotes. And that's where really the business logic lurks. But then we've got a lot of this common code that factors out things like the base application, the base controller, the base service. This is all generic code that can be parameterized and extended through the microservices. It's a really interesting design. And then there's also other stuff here that you need if you're going to write code that's project-specific, like the format of a quote, the quote repository, which is where we're going to ultimately end up storing information persistently, and so on. There's also some reusable helper classes that we'll talk about when we get to that point. And then resources, which do things like define the microservice names, the port numbers, the schema definitions for the quotes, because some of these quotes are going to be using something called the Java persistence architecture, or rather the Jakarta persistence architecture, and we'll talk more about that in a second. That's a common way of being able to do persistence with Spring WebMVC style programs that are synchronous. And then finally, the client side, we have a test driver that's going to send and receive request and response to the different microservices via the API gateway. So they don't actually send it directly to the microservices, they send it to the API gateway, and then that will forward to it'll route to the microservices. So this is the part that does the get and post request proxy, which again just talks to the gateway. And in this particular example, we're going to use retrofit to auto-generate the proxies. When we talked about the previous case study, we explained how you can use the HTTP interface client feature that came in recent versions of Spring. And now we're going to show how to use retrofit. This is also relevant because assignment number 2 is going to use retrofit, so you'll have to understand how that works. Retrofit is very similar to the HTTP interface client stuff we talked about last time, just has a few other quirks that we'll talk about. And we got a utils folder, as usual, that abstracts a lot of common things. And this will also be relevant for some of the stuff you'll do for assignment number 2. So it's good to see the pattern. And there's a resources file that will basically enable logging and set up the port numbers that we're using and so on and so forth. So let's talk about the pros and cons of this particular approach. So the nice thing is that each microservice runs in its own process and potentially could run on its own computer in a data center or a cloud environment. So we're running this in my laptop, so everything's obviously in one computer. But because of the way we've organized this, it's easy to be able to scale it up and scale it out to run on multiple computers. And the purpose of that, of course, is to make the system more scalable, because you could leverage more computing power. And if you put some other stuff in there, which we will not do here, things like load balancing or various types of replication services and failover services, you could make the system a lot more reliable as well. The other nice thing about this design is the clients only need to communicate with the API gateway. They don't have to know anything whatsoever about the organization of the microservices in the back end. So that helps with client programming complexity, because they only have to do one-stop shopping to one port number. And it also helps to some extent with system security, because you can have the gateway be the place that does the checks for things like authentication tokens to make sure that the clients have permission to access the services that they're trying to call. There are some downsides here. Most notably, now that we've got a bunch of microservices and an API gateway, all of a sudden certain things are more complicated to do. So configuration, deployment, testing gets to be more complicated, because you have to figure out a way to deploy these on the different computers you want them to be on. So the fancy word for this is you need more sophisticated orchestration mechanisms. A good example of an orchestration mechanism would be Kubernetes. Docker has similar types of things as well. So in a real production system, you would be using those. And if you work on production systems, there's often people in organizations whose sole purpose in life is to manage the configuration and deployment aspect. And the other issue here, as we've talked about many times, is that synchronous two-way requests and responses may not scale all that well for a variety of reasons. And we'll address that particular problem in the next round of case studies that will use Spring WebFlux, starting probably next week. So that's the end of the overview of this particular case study.